Simple is hard. These are the words I read on a business card of a colleague of mine 9 years ago. We all had our own business cards. Mine said, like, talk is cheap, show me the code. But in the end, his made like a way bigger impression on mine, because I always kept this quote with me, actually. But when I first saw it, I thought, like, that's not true. Simple is easy. Like, I thought these words were like synonyms for each other. But over time, I really learned that they're more like opposites than like synonyms. So let's take a look at the definitions of these words. Easy is a sort of effortless. Like, it might just happen accidentally or like casually. Like, the outcome might happen. Whereas a simple thing takes like continuous effort to like keep working on it and get it to like a simple point. Like I said, like accidental, like out of many possible outcomes, the easy outcome is likely to happen by accident, whereas like a simple outcome wouldn't happen. And a simple outcome is something like essential. So you keep crafting it till you like reduce all the complexities one at a time till you reach like this essential piece where only the core is left or only the essence is left. So if we look at these definitions or words, we see that actually the definitions of the simple one more closely map to something that is hard. Continuous effort, crafting something that is essential. So we can indeed state that simple is hard. And this is also why I don't like the phrase, keep it simple, stupid. I think it's very rude. And I would like to rephrase it as like, make it simple, smarty. If we, for example, take a look at the yin-yang logo. Like, it's something that once you see it, it's very easy to recreate. Like, we can all draw this symbol, it's very easy. But in a world where the yin-yang logo does not yet exist, although it's very simple, it's very hard to actually create this logo that represents this duality. You might be thinking, I'm here at Kotlin Conf, why are we talking about yin-yang logos and stuff like this? Well, today I will talk about FModel, and I believe this frame of mind of looking at simplicity is important to properly understand a library like this. It is a library that at its core only has like 3 elements. It has like the command, the event, and the state that we'll further zoom into in a little bit. I wanted to talk about more things about FModel, but I really want to focus on these core elements for now. Because FModel as a library also has like an actor model, parallel event processing, event sourcing, state stored applications, and other cool mathy things that are way above my pay grade. But just looking at these 3 elements, the first one we find is the command. This is an action we wish to execute in our system. And it sets an intention of something we want to do. It is commonly written in present tense because we are doing that right now. An example of this is register user. It's an intention to register the user. Next, we have events. This is stating facts that have happened. We commonly write this in past tense to indicate that it has happened. So, for example, user registered or user went to conference talk. And lastly, the third element is the state. This is a data representation in a specific point of time. And one interesting thing is that we, using events, we can actually represent different kinds of states, which we will zoom into a little bit later as well. These are the 3 core components or core elements of the FModel library. They're not unique to FModel though. They are like commonly found in like different software use cases and libraries as like recurring core concepts. So as a quick recap, we have the command, an intention, something we want to do with the system. Please register this user. please allow this user to go to the conference talk. We have the event, something has happened, a fact has happened. So the user was actually registered, and the user went to this conference talk. And then we have the state. It is a view or a representation of all our data. And so some user might have the status registered. But what is interesting actually is that the state is the only one where we really zoom into this like data layer, where it's like actually we see how much talks they attended. Whereas with the event, we currently don't really see like maybe what is their username they registered with, or like which talk did they go to. With commands and events, the data is more of an implementation detail. They are completely there, but actually the encapsulation of itself is very valuable. So often we just wanted to know, like, is the user registered, for example, which we will see a bit later. And once we have these elements, we can compose interesting behavior with them. So with commands, for example, once we execute this action or this intention, the result of this might be an event. So we wish to register the user, now the user registered. And we might have some validation with this command. And like if we deny this user, one interesting thing is that actually this event will not happen and will not be stored. So these facts are actually very reliable. Like once we find this event, we know that something has occurred and we can like build upon that. One command might actually result in multiple events. So like we will see like good examples in a little bit in the demo, but quite often it might result in multiple things. And then actually the interesting, maybe most interesting about this is that we can use these events to actually calculate or like create our state. So in the example we just showed, when a user registered, we found that user registered event, but this can be used, the data in that event can be used to like build our state. So we can like look over these events and like calculate the number of talks they went to, for example, and store that in the state. Or find just the original user registered event and store or set the username they used to register to the application. And if we further like encapsulate this behavior, we can see this like long relationship. So we set the intention, something happened, we calculate state. And in more traditional systems, what we most commonly see today is that we store the state. So the current user is stored in the database. Like once they change their email address, we change the email address and we store the new or the changed user to the database. This model is completely supported by FModel, but what is actually way more interesting and what I think is a very underutilized tool is an event source system, where we actually store the events in the database, all the facts that have happened. And with all these facts, we have enough information to calculate any states that we would be interested in. Then any new commands could combine with the current state that is calculated to do any validation, like see, like, is it allowed actually to do this transaction for this, the bank transaction for this user? And once it is allowed, we can execute the command, which results in new events. These events are stored, and this makes it that we're always able to create our application and play events to it. And this is what FModel is about. So it's one model that uses these three elements, the commands with the C, the events with the E, the state with the S, to either support a state stored system, where you can have the current state stored and like make changes to it and store the new state. But in the same architecture within the same system, you could have parts that are event sourced, where you create the states based on your events, all the facts that have happened. Now, this is very theoretical, and I love this theory, but it's very good actually to bridge this gap now to the practical. And I think actually that FModel does this well. So it's a very pragmatic and practical library that you can immediately use. And it has like many use cases or like many higher level things. Whereas today I mostly focused on just this going from commands to events, which is called decide in FModel, and actually producing the state from these events, which is called evolve. And now I want to show you a bit of the demo to actually show it in practice. Let's see if it's here. So welcome to Cooking with Cody. We have a little bit of a recipe website where we can craft our own recipes. And the relationship with the commands and events and stuff is that this down here is our first recipe step. And this can be seen as a command. We want to send this to the system to actually do. And what recipes are very good at is to hide many steps into one step. So it's like preheat your oven, pat the fish, slice the fish, wash your hands, wash your equipment, and halve all the vegetables and stuff like that. So actually it's many steps. But we can actually fire this as one command and have it result into multiple events. What we'll see is that here we will see the state of the current recipe, and we use these ingredients in the recipe. So if we click here, this is our current state, and we use the events from the previous command to actually calculate this. And we see that these ingredients are now used. To show a bit behind the scenes, these are now all the events that have happened. So we can zoom a bit. So we found that actually the oven was preheated to a certain temperature, like the hands were washed, that's good, and like the vegetables cut, etc., etc. And over here, we have calculated the current state of the recipe. So these are the ingredients that are so far used, and we have completed the first step. So this isn't stored anywhere. This is not in a database. This is completely calculated based on the events that have happened. And actually, we can calculate a different state with using the same events, where we can actually calculate the state of the kitchen. So here we have the oven preheated. There's something in the oven, and it's set to a current temperature. Then when we complete another step, or 2 more steps, let's see, I think that will have a result. Oh no, it's still in the oven. So we complete the recipe. Over here, we, in the end, have used all the ingredients, and we built this nice little dish. And in the end, now that the food is served, we find that there's nothing anymore in the oven. The temperature is reducing, it's cooling down, even though it's already turned off. And this is, and having this log of events is super useful, because like these are now all the events that have happened in those steps in cooking. And this is the recipe, just all the used ingredients, which is just some state. But we can always decide later, like actually we're very interested in this state, which allows us to use the same events now to calculate a new state. And it's very good for reporting. So we can actually see, we can actually ask questions to our system, like which method was used to heat the tortillas in step 5. We have 2 options for that. We can use the microwave or the oven. And in this case, the microwave was used, or how many grams of salt were added in step 2. So it's very, at the moment, non-interesting questions, but the interesting part is that we usually get like these random questions from product managers, and we're like, okay, yeah, I can build something for it, but I can't say it's really right now. So in state-stored systems, we have the challenge that we can only go ahead from like this current position in time to the future. We can only implement it now, so only from now on we will be able to tell. Whereas with these events, if we have new questions, we can look at our existing events of everything that has happened, and calculate some interesting new states based on that. So also we see here that we wash our hands after handling the raw fish, and that was the case. Maybe I can actually, so let's see, where's my pointer? To actually have the most interesting thing. Oh, I hope I can share my code. Let me try. No, okay. That won't work, but that's fine. What I wanted to show is that we actually handle all these events in order. So if we were to change the order of like washing your hands and then handling the raw fish, it would actually state here at step 3 of like the hands were washed before handling the raw fish, so like undoing the point. And this is, I think, the like a real power of event source systems, is that actually the relationship between the facts that happened is very valuable data, even not actually looking at the detailed data that is within there, of like how much water was used, etc., stuff like that. Let me quickly get back to the presentation. Yeah, I'm a bit short on time, but this is like all the code that is kind of needed to like set up a route in Ktor, accept all the parameters, calculate all these events, which is done here. It starts with an initial recipe state and then evolves. So it actually applies all the changes from each event it has in the database that is related to this recipe. And once you do that with every event, you end up with the state, the current recipe. We are able to fire a new command on that. So after that, we receive new events, and we can view this as the evolved recipe. Once we apply those new events also to this recipe. And to be able to use them later, we also store these events. And then we kind of respond from that. It is, yeah, what I want to say, like an event source system is a very simple system, but to actually use it is still pretty hard, or like to properly understand. But I think it's would be a very valuable thing to actually use in more and more systems. Because my final point is that, sorry. Let me just zoom here. Is that with event source systems, time is really on your side. So this is the state after the first step, the second step, and the sixth step. And with a state stored system, we would only see the final state. But here we're also able to see what happened in the meantime. So that something was in the oven. So yeah, simple is hard, but simple is very much worth pursuing. That's it. Thank you. Please remember to vote, like if you have. And I find that conferences are like great place to learn about new things, and it's very usually just like at lunch and places where you talk about each other. These are currently some of my favorite tools. If you haven't used one of those, please try it out, because I'm very impressed by those tools. And yeah, that's it.